All right, so let's work through a few of these ray diagrams. So I have an object placed 13 centimeters away from a concave mirror with a focal length of 11 centimeters, and I want to draw a principal ray diagram that show the approximate image and location, and I'd like to check that the image is drawn correctly. When I see things like this, I start with the thin lens equation. So this is number 7, and I say that 1 over f is 1 over dO plus 1 over di. I solve for the things that I don't know and go from there so that I sort of know how to orient things on the page. So I have the focal length is 11 centimeters, and the object distance, that's dO, is 13 centimeters. And di I don't know, so let's solve for it. Okay, so if I solve for di, I can subtract 1 over dO on both sides, and that will get rid of this term right here. And then I can say that 1 over di is 1 over f minus 1 over dO. And then I take the reciprocal of both sides. So 1 over di to the negative 1 power will just be di. And that's what I'm trying to solve for. So I'll take the negative 1 of both sides. And that lets me say that di is 1 over f minus 1 over dO to the negative 1. So now I can plug in numbers. So this is 1 over 11 minus 1 over 13 to the negative 1. This is a concave mirror, so it's a mirror that looks like this. So the rays are going to be coming in from the left-hand side like that. And that is a mirror, whenever you have a mirror like that, that is a positive focal length. So if we come over here on this thing, right, a concave mirror is this column right here. So that has f greater than 0. So we're going to put that 11 centimeters is greater than 0 into this equation. If this was a convex mirror, then we put f in as negative. Okay, so now I can solve for this. So I'll go 11 to the negative 1 minus 13 to the negative 1, and then I'm going to push enter, and then I'll take that whole thing to the negative 1 power. That's just like a quicker way for me than dealing with all the parentheses, but you can put it into the parentheses as well. And that equals 71.5. Okay, so the fact that this is a positive number tells me that this is a real image. So di greater than 0 is real. And we will also see that we're expecting whether the image is going to be magnified or not. So magnification is sorry, get this up for a second. Well, I'm not going to pull it up on here, so I'll just write it down. Is going to be minus di over dO, and that's an equation that you can find on your equation sheet. I was trying to pull up the equation sheet, but I didn't find it quickly, so I'm stopping there. So this is going to be negative 71.5 divided by 13, which is big. So we'll do that divided by 13. And so that's 5.5, and I need to add that negative, so this is negative 5.5. Okay, so my image is going to be 71 centimeters away from the mirror, and it's going to be upside down and 5.5 times as big. So this is a pretty tricky one to draw, just because to keeping everything to scale and keeping your lines, right, we have to get 11 and 13, which are right next to each other. And we also have to be able to draw 71.5. So I know that everything is going to be to the left of the mirror. I'm not going to form a virtual image. I'm going to form a real image. So the real image will be on the left-hand side of the mirror. So I'm going to go ahead and put the mirror over here. And I'm not even going to think about the curvature of this mirror. Instead, I'm just going to like draw a straight line. Like that. So I'll draw my rays as reflecting off of this straight line. It'll be a little bit easier that way. And then I'm going to draw my principal axis of my mirror like this. And now draw it going straight across. And let's go ahead and draw things to scale. So I need to be able to resolve 71 centimeters away. So, and I can see, actually, I have a ruler here that's got an inch scale on it, so I'm going to use the inch scale. If I make each one of these half inches equal to 10 centimeters, I'll be able to go 20, 40, 60, 80 centimeters like that. So that seems like it'll work. So I will say my scale is 1/2 inch equals 10 centimeters. Okay, so there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, and so my focal point is at 11 centimeters, so I'm going to draw F as being right here. My object is at 13 centimeters, and my image is going to be 5.5 times bigger. So I don't want to draw my object very big. So my object is going to be, there's probably 15. So we'll put 13 right here. And now I'm going to draw a pretty short object because that'll give me space to put an arrow that is hopefully upside down because this is negative and out here somewhere. Okay, so let's draw our 3 rays. So the 3 rays are in parallel and out through F. So we'll go in parallel. And parallel will be parallel to this principal axis. So that right there is the principal axis. And so I'm going to draw a ray that leaves the tip of the arrow in parallel. And then when it hits the mirror, it bends and it goes out through F like that. So that's what that ray does. In through F and out parallel. So I'll draw a ray that starts at the tip of the arrow, goes in through F, and then it comes out parallel. And one thing to point out here is that I drew this as going to this kind of dashed line rather than my curved line, and you would get a pretty different answer depending on which one you did. And this is kind of a limitation of drawing these things to scale. If you want to be perfect about this, then you should get try to draw a circle. So the center of a circle should be, this is 22, right, is twice the focal length. So if the focal length is 11, then at 22 centimeters, that should be the center of a circle. And if you can kind of imagine a circle, that is there, it probably goes like that, and like that. And this is what your mirror probably really does. Like that. So that's what the mirror really does. So you can kind of draw it bouncing off of the mirror, but it always works okay to just draw it as bouncing off of this kind of line that is straight. And then our third one is going to come in and hit the center of the mirror. And then I want to have this angle here match this angle there. So it's going to leave with an angle like that. Looks pretty good. Right there. And I kind of purposely drew this pretty badly to show you how yours are going to look. And so ideally, all 3 of these lines would cross at one spot. But what we have done here is that, man, my image is somewhere between here, here, and here. I think partly what has gone on here is, so this isn't a very good ray diagram. I'm trying to decide what is the worst. This is a hard ray diagram to draw, and I won't ever ask you to draw a ray diagram like this in the on a test. But right, so I'm going to sort of guess that probably my image, I don't know, I'll sort of split the difference. It's somewhere between 30 and 80 centimeters. So I have a 30 centimeter where they cross, an 80 centimeter across, and like a 55 where they cross. So I'm going to draw it, I don't know, here-ish. And we'll say that that is approximately DI. We do have an inverted, right, it's upside down arrow, much taller, so I buy that that's about 5.5 times longer than the object. And we were expecting about 71.5 centimeters, and we got, I don't know, somewhere around in there. So this is fine. When you have ray diagrams that aren't working, the thing that I don't want you to kludge is the 3 incoming rays. Don't ever draw a ray that doesn't go through F if it's supposed to be going through F, right? Don't ever draw a ray that is far off of parallel if it's supposed to be parallel. As long as you're doing okay with that, I don't mind that your rays don't cross. I maybe did a little bit of overkill here. This is pretty bad. So try not to do as poorly as I did, but this is a hard ray diagram to get right. So much like a few degrees off in how I drew these makes a big difference all the way out here. Okay, so that's the first ray diagram. Let's do the second. So an object is 13 centimeters away from a convex lens with a focal length of 11 centimeters. Let's draw a principal ray diagram that show the approximate image location. So this is the same problem, but instead of it being a concave mirror, we're going to be dealing with a convex lens. And a convex lens looks like that. Okay, so let's return to this table here and see what we're looking for. So we have a convex lens right here, and we just did a concave mirror. So these occupy the same column in the table, which means that we're expecting the same type of behavior here, okay? So we have an object that is between the focal length and twice the focal length, so we're expecting a real, inverted, and larger image. F goes in as positive, so actually the numbers in the thin lens equation that we did right here are not going to vary at all. We are expecting a real image that is 5.5 times bigger than the object that is 70 or so centimeters away from the lens. Okay, so I'm not going to redo any of the math because the math is the same. Only now I'm drawing a converging lens. So let's draw our converging lens. And we have a converging lens. We're going to draw the rays coming from over here. But now rays don't bounce off of a converging lens and back to the left. Rays will pass through and bend in the converging lens. So the location of our real image is actually going to be formed over here behind the lens instead of over here like it was for the mirror. So I'm going to draw my principal axis of my lens as going straight through like that. And actually, I'm going to think about where I put this lens a little bit before I do that, because that wasn't the best choice. I want to be able to resolve 70 centimeters on the right-hand side of the lens, but I only need to be able to resolve 13 centimeters over here, right? Because I know that DO is 13, I know that F is 11, and I know that DI is 71.5, and I also know that magnification is negative 5.5. Okay, so I've got to have 70 centimeters over here and only 13 centimeters over here. So I'm actually going to put my lens pretty close to the left-hand side, and that'll make it a little easier for me to resolve everything. That didn't erase very well, but you just have to believe me. Okay, so now I need to draw things to scale, and let's keep with that 1/2 inch is 10 centimeters. Okay, and now a mistake that a lot of people make is where they start 0. So I'm going to draw a line here that looks like this. and this is 0 centimeters. Okay, here is not 0 centimeters. Here is not 0 centimeters. 0 centimeters is this line that goes straight through the middle of the lens. So I'll start here, and there's 10 and 20, 30 and 40, 50 and 60, 70 and 80, 90 and 100. And then over here on this side, we'll again measure from 0, and I'll put that is 10, and there's 20, like that. Okay, so now let's put the focal length at 11 and my object at 13. And I'm going to draw a short object again so that I can make a big image. And now I need, for this lens, I need to have an F here, and I also need to have an F here. Right, both sides of the lens, and this is true for mirrors as well. Both sides of a lens and mirror have a focal point. Okay, so we will go with a lens. We have the three rules. So one is in through F, out parallel. The second rule is in parallel, out through F. And the third for a lens is easier than it is for a mirror, which is in through center. And instead of reflecting with the same angle, this one doesn't bend. I like to start with the third one for a lens because it's the easiest one to draw. So I'm going to draw a ray that starts at the tip of the arrow, travels through the center of my lens, and doesn't bend. And there it goes. And now I'm seeing that where I wrote out my rules is going to be probably the location where I'm expecting to see this image, but oh well. Okay, so now let's go back up to the first one, in through F and out parallel. So we'll go start at the tip of the arrow and go in through F. It bends, and it goes out parallel. Like that. And they are crossing at, I don't know, 50 or 55 centimeters or so, which is better than I did on the last ray diagram at least. And the next one will be in parallel. And out through F. Oof, let's draw that a little better. I wish I hadn't done it with. So you can see what I did here is I did in parallel okay, but my out through F kind of missed F a little bit, and it's making it look like these lines are never going to cross. So I'm going to ignore that one and turn it just a little bit more. Like that. So we'll get rid of this line. And now I have lines that are crossing here. I have a line that's crossing here and a line that's crossing here. So this is sort of my triangle that I've made where my things intersect. I was expecting to have an image at 70 centimeters, and this is sort of right in the middle in there anyway, so I'll say that it looks kind of like that. And there is that one. Okay, so that shows you drawing real images for mirrors and lenses, and in the next video we will pick up with problem number 9.